to another interesting and educational segment on the Psychologist NDTV with me, Dr. Blessing Ntamu. I hope you're having a good day out there. Today we are going to be discussing chromosomal anomalies, chromosomal abnormalities or aberrations. Before we go further with this discussion, if you're new to the Psychologist NDTV, kindly click on the word subscribe just beneath the video to subscribe to this channel free of charge, and also click on the bell sign to enable notification so you can be notified of all of our future videos. It's always educational and informative, and you don't want to miss out on any one of them at all. Now let's go right into discussing chromosomal aberrations. Now these aberrations or anomalies usually occur during the process of meiosis when chromosomes get intertwined. If you recall from our previous videos, we mentioned that meiosis is a type of cell division that usually occurs in sex gametes to give them the haploid number of chromosomes. Okay, we had said that all other cells in the body have the diploid number of chromosomes, which is 46 chromosomes, or the sex gametes, the ovum and the sperm cells, have the haploid number, and this haploid number is achieved through the process of meiosis. Now during meiosis, we said that chromosomes can get intertwined, and in the process of the cell division, some anomalies could occur. Now some of the anomalies that could occur during meiosis when chromosomes get intertwined is deletion. Now this happens when a segment of the chromosome breaks off and falls off with some genes. Okay, so during the process of cell division, some segments of the chromosome could actually break off from the original chromosome and then fall off with some of the genes. This implies that the individual loses some genes, and there are great implications for the individuals. Okay, that is deletion. And after that, we have inversion. That's also an aberration in which segments of the chromosome could cut off from the main chromosome, and then it turns around and gets reattached to the chromosome, the original chromosome, but in an inverted form. So this also leads to abnormalities in the organism that's formed eventually. After that, we also have a process whereby the chromosome can get duplicated, and when there's duplication of chromosome, there's also going to be anomalies that could have grave implications for the individual. Another thing that could happen is what we call translocation, a situation whereby a segment of the chromosome could break off and then go off and get attached to another chromosome. Now this is similar to crossing over, except that crossing over occurs only in non-homologous chromosomes. Okay, so these events could take place and they will lead to chromosomal abnormalities in the organism. We also have a situation known as non-disjunction. Now during the process of cell division, there's a stage where the chromosomes are supposed to separate during meiosis. Okay, now occasionally it happens that these chromosomes do not separate as they ought to. So when the daughter cells are formed, one daughter cell could contain both chromosomes, and then the other daughter cell could be empty, having no chromosome at all. Okay, so when this happens, it's known as non-disjunction. Now if two gametes in which non-disjunction occurred fuse together, you can have a case of polyploidy, where you have several chromosomes instead of the normal number, or where you have missing chromosomes because an empty gamete, okay, that did not pick up any of the chromosome at all because there was non-disjunction, you attach it to another cell, and then you have missing chromosomes. I wonder if you're following me on this, but when we go further, maybe would understand better. Now on to the discussion of some syndromes that result from chromosomal abnormalities. Okay, the first syndrome we're going to be discussing today is the Cri-du-chat Syndrome. Cri-du-chat Syndrome. According to Genetic Science Learning Center 2014, the Cri-du-chat Syndrome was discovered by Monsieur Jérôme Lejeune in 1963. Monsieur Jérôme Lejeune is also credited with discovering the chromosome abnormality that causes Down syndrome. Okay, now Cri-du-chat is actually French and translates directly to mean cry of the cat. Now, this is because individuals that develop this syndrome usually have a specific unique cry that's very similar to the cry of a cat. So Cri-du-chat Syndrome was named after that characteristic. Now, this happens as a result of deletion. Cri-du-chat Syndrome happens as a result of deletion in the fifth chromosome. The short arm of the fifth chromosome, breaks off and falls off with some genes, and that leads to the syndrome known as Cri-du-chat syndrome. If you recall, also we had said that these chromosomes are sequentially arranged, and each chromosome number stands for a particular set of chromosomes. Okay, so chromosome number 5, there's deletion that occurs there at the short arm. A segment of the chromosome breaks off and gets deleted, falls off with some of the genes, and it results in Cri-du-chat syndrome. Now, babies that are born with this syndrome, like we said, they cry in a particular way, like cats, due to poor development of the larynx. Okay, so they have this particular cry that distinguishes them. And this syndrome reduces as they grow to about 2 years old, making it less noticeable and then non-diagnosable as well. So it cannot be diagnosed sometimes above 2 years old. Now, this syndrome is genetically transferred. Okay, so it can be transferred from parents to offspring. Okay, and there are other associated problems when a child has Cri-du-chat syndrome. Some of the problems the child may have is the child is likely to have heart problems. The child is likely to have respiratory problems as well. The child is going to have microcephaly, that's a small head size, and other associated problems. Poor muscle tone, skeletal defects, and hearing and sight problems are also some associated problems that result as a result of the Cri-du-chat syndrome. And now let's move over to the next syndrome we're going to be discussing today. The next syndrome we're going to be discussing is the Klinefelter Syndrome. The Klinefelter Syndrome is also known as the 47XXY syndrome. Now, this syndrome occurs because of non-disjunction. When there's non-disjunction at the 46th chromosome, leading to the individual having 3 chromosomes on the 46th chromosome, the 23rd pair of chromosome, instead of 2 chromosomes. Okay, the 23rd pair of chromosomes, like we had mentioned, are the sex chromosomes, and in the women it is XX, and in the male it is XY. Now, an individual that has Klinefelter syndrome will have XXY. This is because there was non-disjunction, so there was non-segregation during cell division. So one of the gametes had double chromosomes, okay, had XX or XY, because there was no segregation. If there was segregation, the gametes would have had the haploid number with either gametes having either X or Y. But when there's no segregation, you have one empty cell and then one other cell having the 2 chromosomes. So one cell now has XX or XY, and then it fuses with another cell that has either an X or a Y. So a person with Klinefelter syndrome will have the chromosome number XXY on the 46th chromosome. So instead of having 46 chromosomes, because of that extra chromosome, that individual will be having 47 chromosomes. That gave rise to the name 47XXY. Okay, so it's either called Klinefelter syndrome or 47XXY. There's an extra chromosome, and this has grave implications for the individual. Let's look at some of the implications of the Klinefelter syndrome. Now, most individuals with the Klinefelter syndrome or the 47XXY syndrome will develop into males. Why? This is because the presence of the Y chromosome signals development of the male sexual characteristics in the individual. So you have majority of individuals with Klinefelter syndrome developing as males. You have a few of them being intersex or hermaphrodite, and then just very few will be females. Not every individual with the 47XXY chromosome type will develop Klinefelter syndrome. Now, for the individuals with Klinefelter syndrome, the most significant defect is a lack of production of spermatozoa, because they have a low testosterone. That's the hormone that's responsible for the development of the male sexual characteristics. So in spite of being male most of the times, they lack adequate amounts of testosterone in their bodies, and because of this they develop in a specific way. Like we said, the most significant effect is that they are most likely to have low sperm count or unable to produce sperm, and so they are unable to have children. Usually the Klinefelter syndrome is diagnosed when males begin to seek a solution to infertility. Now let's go to their looks, other ways that it affects them. Usually these individuals will have a low muscle tone. Yeah, they will have unusually long arms and legs, disproportionately long arms and legs. That's to say, when you look at the length of your arms and their legs, it will be disproportionate to their bodies. Okay, now they will have a lot of belly fat. Okay, they are going to have broad hips, and this is usually unusual with men. They're also they might develop breasts during puberty. That's also unusual for a man. And they will have low development or poor development of facial hair, which is also a characteristic for males during puberty. Now they might have moderate, to low to moderate learning disabilities because of Klinefelter syndrome. Now, what's the implication of all of this? A teacher that identifies some of the symptoms, if it's diagnosed in time, it actually can be corrected using hormonal injections. But if it's not corrected and you have a child like this in your class during puberty, they are going to be troubled. They are going to be they are going to have identity crisis because they look more like women than men, and no facial hair, development of breasts. All this will trouble them. So the teacher has to be able to reassure them that it's okay to be different. You have to be able to deal with them specially because they're special children. And like we mentioned, they might also have learning disabilities, which will require special attention when you're teaching them. That's why it's important for a teacher to be abreast with all of this, to know about these disabilities, and to be able to identify them in their learners as well, so they know how to handle those special learners. Now over to the next chromosomal abnormality. The next chromosomal abnormality we are going to discuss is the Down syndrome. Down syndrome is also known as Mongolism or trisomy 21. It is quite similar to the Klinefelter syndrome because it's also the presence of an extra chromosome, but this time the extra chromosome is not present in the 23rd chromosome like in Klinefelter syndrome. Is rather present in the 21st chromosome. So when you have an extra chromosome in the 21st chromosome, that's what is called Down syndrome. It's also as a result of non-disjunction in one of the parent cells. So when there's non-disjunction and one of the parent cell retains the complete number, the diploid number of chromosomes, and then it fuses with another chromosome that has the haploid number of chromosomes, instead of having two haploid numbers fusing and becoming a diploid, you have one diploid and one haploid, and you have a triploid. Okay, that's why it's called trisomy 21. 3 chromosomes, an extra chromosome, and in the 21st chromosome. Now, it is said, according to Genetic Science Learning Center 2014, that non-disjunction is more likely to happen in older women. This is perhaps why older women are more prone to having Down syndrome children. Okay, so if we can have our babies earlier, the better. The earlier the better. Our body is in top form, all the hormones are being produced in the required amounts, and the process is usually easier and better. Now let's look at some of the characteristics of an individual that's suffering from Down syndrome. A child with Down syndrome will have abnormally shaped ears, is likely to have low muscle tone, is likely to have upwardly slanting eyes, likely to have folds or creases in the inner part of the eyes. Okay, these children also appear floppy. They're likely to have some learning disability. Okay, sometimes Down syndrome co-presents with autism spectrum disorder and also with attention deficit disorder. Yeah, so look out for these children. If you have them, you have to deal with them with patience. You require extra skills to be able to put them on the proper learning track because they might have learning disabilities. Okay, now let's move over to the very next chromosome abnormality that we're going to be discussing today. The next and the final chromosomal abnormality we're going to be discussing is the Turner's syndrome. Now, the Turner syndrome, individuals with this Turner syndrome have the genetic presentation XO. So this is also due to non-disjunction, but in this case, we are not talking about an extra chromosome, but we are talking about a missing chromosome. So instead of having XX or XY, the individual has XO, that's X and nothing on the 23rd chromosome, okay, because one empty chromosome fused with one haploid chromosome. Again, instead of having two haploid chromosomes fusing, because there was non-disjunction and one gamete contained the diploid number after cell division, one gamete was left empty. So when this empty gamete fuses with a haploid gamete, then you have XO. And because it's only the X there and no Y chromosome, of course it's going to be a females. So females with the Turner syndrome are usually stunted in growth, and they also have poor development of the sexual characteristics. They are usually likely dwarfs, like I said, and they're usually sterile females, most likely to be sterile females, and there may also be other implications like learning disabilities and others. So that's about it for chromosomal abnormalities. And just before we wrap it up on chromosomal abnormalities, I'm going to try to run over what I can, but you can do yourself a favor and go through the video from beginning to end just to ensure that you got everything correct. So we said that usually during meiosis, that is the cell division that takes place in the gametes, you might have chromosomes intertwining together, and any of the following could happen, leading to chromosomal abnormalities. You can have deletion of a segment of the chromosome, and it gets deleted with some genes, leading to grave implications for the individuals that formed. And then you could also have a translocation, where a segment of the chromosome gets breaks off and then attaches to another chromosome. You could also have an inversion, where a segment of the chromosome breaks off, turns around, and then gets reattached to the same chromosome. You could have a duplication, where a particular chromosome duplicates itself. And you could also have a situation where there's non-disjunction, when the chromosome fails to segregate during the first stage of meiosis, during cell division, where there's supposed to be segregation, and the chromosome divides and goes into two different daughter cells. There's no segregation, and those two daughter cells are formed. One contains both chromosomes and the other is empty. When you have this, it leads to chromosomal abnormalities. And we talked about the Cri-du-chat Syndrome. That's due to deletion on the 5th chromosome. Yeah, and then we talked about Klinefelter Syndrome, also known as 47XXY, due to non-disjunction, and happens on the 23rd pair of chromosomes. That's the sex chromosomes. We said the individuals are mostly males. There could also be intersex or hermaphrodite, and then in rare circumstances there could be female. The major characteristic is that they're likely to be sterile males because they lack adequate testosterone secretion. They're usually likely to have low sperm count or no sperms at all, are unable to have babies. We also mentioned Down syndrome, and that's also known as Mongolism or trisomy 21, and that's where you have non-disjunction leading to an extra chromosome on the 21st chromosome. We mentioned that these individuals will also have some learning disabilities. They have some particular characteristics like slanting eyes, slanting upwards, creases in the inner corners of the eyes, small nose, unusually shaped ears, and all of those. And then the last one we mentioned was the Turner syndrome. Turner syndrome occurs in women also as a result of non-disjunction. In the 23rd chromosome, you have XO instead of XX or XY. These individuals are usually stunted in growth, and they have poor development of sexual characteristics, and so they're likely to be sterile females. Remember that we mentioned that Down syndrome non-disjunction is more likely to occur in older females. So that's probably why older females are more likely to have Down syndrome children. When you can help it, it's better to have your children earlier, before the age of 35 actually. But when you cannot help it, or when there are circumstances beyond your control, well, you can go ahead and pray God to see you through. That's so much for today. And like I said, keep it locked on to the Psychology NGTV. Make sure you subscribe to this channel and enable notifications so that when a new video is uploaded, you will be notified. If you haven't subscribed, this is the time to do so. And I'd like to interact with you on social media, so please follow me on Instagram at The Psychologist NG and on Twitter at The Psychologist NG. Always a nice time with you. I know these topics are a little complex. If you have questions, leave them in the comment section and I will gladly answer them. Also leave other comments. Let me know what you think. Let me know topics you might want us to discuss. I'm looking forward to hearing from you. Also like this video and share with people who need to learn about these things. Thank you for watching and have yourself a beautiful day. God bless you. Bye.